Hello everyone, myself Fans. Today we are going to solve the again problem from topic partial differential equation. Question is given here. Eliminate the arbitrary function f and small f and capital F from the given function here. Y is equal to f of x minus of 80 plus of f of x plus of 80. Let's solve the problem here. Given function is y is equal to small f of x minus of 80 plus of capital F of x plus of 80. Let this equation 1. We have to form the partial differential equation to eliminate the arbitrary constant. Here arbitrary function is small f and capital F. So differentiating equation 1 partially with respect to x. First we have to equation 1 differentiating partially with respect to x. This gives del y upon del x, and f of x minus of 80 differentiating with respect to x. This gives f dash of x minus of 80. Here t is the function, so differentiating here x is the function of x, so we have to differentiating here x with respect to x. This gives 1 plus of capital of f of x plus of 80 differentiating with respect to x. This gives f dash of x plus of 80, and again here x differentiating with respect to x. This gives 1. The given equation del y upon del x again differentiating with respect to x. This gives del 2y upon del x square. Again here f dash of x minus of 80 differentiating with respect to x. This gives f double dash of x minus of 80, and again x differentiating with respect to x. This gives 1 plus of here capital F again differentiating. This gives x plus of 80, and x differentiating with respect to x. This gives 1. Let this equation 2. And equation 1 partially differentiating with respect to t, we get again we have to equation 1 partially differentiating with respect to t. This gives del y upon del t is equal to here f of x minus of 80 differentiating with respect to t. This gives f dash of x minus of 80, and again minus of 80 differentiating with respect to t. This gives minus of a plus of f capital F of x plus 80 differentiating with respect to t. This gives f dash of x plus of 80, and again 80 differentiating with respect to t. This gives a, and from here again we have to differentiating del y upon del t with respect to t. This gives del 2y upon del t square is equal to here minus a is already present here, and f dash of x minus of 80 differentiating with respect to t. This gives f double dash of x minus of 80, and here constant minus of a is already present, and again minus of 80 differentiating with respect to t. This gives minus of a plus here capital F differentiating again f dash of x plus of 80 differentiating with respect to t. This gives f double dash x plus of 80, and here a is already present, and 80 differentiating again with respect to t. This gives a. So from here del 2y upon del t square is equal to, from here minus a into minus a is plus a square, so we have to here is also a square into a, so we have to take an a square is common. This gives f double dash of x minus of 80 plus of capital F double dash of x plus of 80. Let this equation third. And from from equation second and third we have to eliminate the arbitrary function. So from once again we can also write the equation third in the form of a square is taking here, this is 1 upon of a square del 2y upon del t square is equal to f dash double dash of x minus of at plus of capital F double dash x plus of at. Let this equation third, and from equation second and third here comparing the equation second and third here, if right hand side are both are equal, then we have to equate the left hand side also equal. So equation second of left hand side is del 2y upon del x square, and equation third of left hand side is 1 upon of a square into del 2y upon del t square, and this is the required partial differential equation of the given problem. Thank you class, and thank you for watching.